Hey guys, how's it going? Mr. Dorado here with yet another video for you guys. This video will be on solving compound inequalities. Okay, so we've been talking about inequalities and just how to graph them on a number line and what they mean. We've talked about how their solutions are actually solution sets, so it's a collection of numbers rather than just one particular number. So now we're going to extend that a little bit, and actually we're going to talk about compound inequalities. Okay, now the one we're going to be focusing on today is the OR inequality. There is both and as well as OR inequality. So let's go ahead and first identify and define what a compound inequality is. So a compound inequality is an inequality that consists of two or more inequalities connected by the words and or. Okay, so it's an inequality that consists of two or more inequalities connected by the words and or. Now, all that means is, excuse me, is that we have an inequality now that has a little bit more of a restriction as to what our solution set will be. Okay? So as we go ahead and get started, let's go ahead and see if we can work with a regular inequality so we can remember how to write the inequality given the graph. Okay, so we're going to focus on some that we've been doing in the past, and now we're going to look at a brand new one. So let's go ahead and see how we can do number one. So if we look at this inequality here, we see that it's a closed circle and it's being shaded to the right. So like I said, we can always choose a variable. I always like to choose x, and I see that it's the number -2. So I always like to write it down there with a space in between. The reason for that space is in order to figure out what, symbol I have to use in order to represent this inequality. So right off the bat, I can see that it's a closed circle. So I know I'm going to have some sort of equal to. Okay, now because it's being shaded to the right, okay, I know I can do a greater than symbol. Okay, if you guys remember, I always use these little arrows over here. See how I just trace the outline of that arrow and it looks like a greater than symbol. Okay, so that's one way of doing it. Another way of doing it is just understanding that the values on this side, guys, are all greater than -2 on the number line. Okay, so I'm shading to the right is greater than, the left is less than. So my inequality here is x is greater than or equal to -2. So let's go ahead and write that as our verbal translation. X is greater than or equal to -2. Okay? Alright, so that was basically some stuff that we've been doing before. Okay? Now let's go ahead and talk about a compound inequality, and we will talk about how we would verbally translate this particular graph. So first off, I'm going to focus on this part right here, guys. So let me go ahead and highlight it for you. I'm going to focus on this right here first. Okay, so what do I have? I know that, again, I'm going to use x as my variable, and I see that there's a -3. Again, leave a small gap there so I know what symbol that I have. So I know I have to insert a symbol in there. Now it's just up to us to find out what symbol we have to use. So this arrow is going to the left. So remember, if your variable is already on the left-hand side, you just have to write down a symbol that looks just like where the arrow is pointing, and that looks like a less than sign, which makes sense because less than is to the left, right hand side is greater than, okay? Now we do have a closed circle, so I know I have to do an equal to sign under there, okay? So x is less than or equal to -3. Now, we're not done yet because, yes, all those are solutions, or I can have solutions on this side. So notice what I just did. I said, or I can have solutions on the right-hand side, which would be what? Well, once again, let's go ahead and write my inequality. So it's x and 6. Now, what symbol do I have to use there? Well, it looks like I am going to the right. We know right is greater than, and if you trace that out, and you'll actually see that it is a greater than symbol. Okay, and it again is a closed circle, so it has to be equal to as well. So let's see. We have a compound inequality now. Let's see if we can translate that verbally. So we have that x is less than or equal to -3, or x is greater than or equal to 6. Okay, now this was the key word here, guys. Or. Okay, notice how my arrows are going to opposite sides. So you either go to the left or to the right. Notice how we're shading either to the left or to the right. There's only just a small gap right here that isn't shaded, because we're only going to the left or to the right. You guys are going to keep hearing me say that. If you have to go in both directions, left or right, and actually, well, then we're going exactly just like that. We're doing an or statement. You're going to have solutions that are to the left, or there's going to be solutions to the right. So here we have our first compound inequality. So let's go ahead and see if we can come up with a few more inequalities. So let's see what we got here. I know I have an x and a 0. Okay, so again, I'm focusing only on this side right now. So let's go ahead and figure that out. So what symbol do I have to use? Well, it's going to the left, so this is a less than, and then it's an open circle, so I don't need to use an equal to. Okay, or my solutions can also go to the right. So again, or my solutions can go to the right, which means I have an x and an 8, and because I'm going to the right on a number line is greater than, so I have x is greater than 8. So my entire compound inequality is x is less than 0 or x is greater than 8. Okay, now let's take a look at number 2. Well, there's only one way we're shading here, and it's only to the left. So again, all I'm focusing is on this. So let's go ahead and type our inequality statement here. So it's x and 7. Now what symbol do I use? Well, it's going to the left. So less than, okay? And there is, or rather it is shaded right here. It is a closed circle, so I do have to have my equal to under there. So you would say that verbally x is less than or equal to 7. Okay? Now, notice again, the first one was a compound because we had the or statement. Notice how there's shading to the left and to the right, okay? Because we have two different scenarios. We have either the left or the right that can be solutions, okay? So that's how you'll know it's an or statement. Here, I'm only going to the left on number 2. So that's just a regular inequality, okay? So it's x is less than or equal to 7. Okay, let's take a look at number 3 and number 4, and then I'm going to have you guys try 5 and 6 on your own. So again, if it helps, guys, as soon as you see that there's two types of shading here, focus on one of them first and then do the other. Again, as soon as you see that there's a gap here, guys, And I'm going to color this in yellow. See how there's a gap here that wasn't shaded at all? That gap is where you know you have to write the statement or. Okay, I'm either going left or right. That's how you'll know you have a compound inequality that is an or inequality. If there's a small gap right there, you either go left or right. So let's continue on with this. So I'm going to focus on this left side first. It's x and a 5. Remember, I always like to write the variable first and the number, and then what is in between them? Well, the thing that's in between them is a symbol we're going to use. In this case, because we're going to the left, it's going to be a less than, and because it is a closed circle, it takes an equal to sign. All right, so I'm done with that left side. Now I have my or statement. So or x and 9. And once again, which way am I shading? Well, in this case, because I'm going to the right, that's greater than, so greater than. And it is not a closed circle, it's an open circle, so I don't need to put an equal to sign. Okay, again, you can either think of it that way, guys. Left is less than, right is greater than. Okay, now keep repeating that over and over again. Left is less than, right is greater than. Or, like I said, if it has been helping you guys to do this, and remember, this trick only works if the variable is on the left side, like you see here. See how my variable is always on the left side of the inequality? It only works there, but look at how my arrow, look at what symbol my arrow is making. It's making a less than sign. Hence why I have x is less than or equal to 5. Here on the right hand side, notice if I trace the arrow, what kind of symbol am I making? I'm making a greater than symbol. Okay, so let's do number 4. Once again, right away, guys, if you notice that there's a gap, just like there is right here, right? There's a gap. You know this is an or statement. Okay, so let's go ahead and take a look at this left side first. Let's write our statement. This is x and -3. Now, which way do I shade? I'm shading to the left, so it's a less than, and it does not require an equal to because it is an open circle. Now I have an or, so or x and 10. Which way am I shading? I'm shading to the right. So again, to the right is greater than, and because it has a closed circle, I need an equal to. So my entire statement reads x is less than 3 or x is greater than or equal to 10. All right, guys, why don't you go ahead and pause the video right now and try out number 5 and 6. All right, guys, let's go ahead and see how you did on 5 and 6. So 5, you'll notice that there is no gap between two shaded regions because there's only one shaded region. It's only this one being shaded to the right. So let's go ahead and write our inequality. So it's x and -5. Again, always start with your variable first, then your number. Okay, now which way am I shading? I'm shading to the right. So again, you can also think of this little symbol that I drew here as an arrow. Check this out. See how that looks like an arrow and it's pointing to the right? That's how you know you're writing the right inequality symbol. So it's going to the right, and because it is closed, it has to take a equal to sign underneath it. So x is greater than or equal to -5. No need for an or statement because there's only one way that's being shaded. Here we do have two sides that are being shaded, and there's a gap in the middle. And again, get used to, if you see the gap, make sure you write or. Okay, so let's go ahead and do that left side first. An x and a 0. Which way is my arrow pointing? It's pointing to the left, so I'm going to make a symbol like that, a less than symbol, and there is an open circle, so no need for an equal to sign underneath it. Now I have my or statement. Once again, x and 11. Which way am I shading? I'm shading to the right. The right is greater than, and again, no need for an equal to sign underneath it because it is an open circle. So I hope you guys got those two correct. Make sure you guys ask me if for some reason that doesn't make sense, or go ahead and look up top and rewind the video for some of the problems we did previously. We won't always have something nice like a graph or even just a simple inequality already given to us. Sometimes we actually have to solve the inequality, then graph it, okay? So why don't we actually go ahead and take a look at number 7 and 8 as a few practice problems, and then you guys are going to try out 9 and 10, see how you guys can do on those. So number 7 says that we're given two different statements separated by an or. So if you guys remember up here, and let me scroll back up, every time we had an or statement like here, we had shading to the left and to the right. To the left and to the right. That's going to happen here once we have our inequalities rewritten. Okay, so let's go ahead and solve this inequality here on the left. We want to solve for x, so first thing we do, get rid of the 6. You have 2x is greater than 14 divided by 2. So we get x is greater than 7. All right, so we have our first inequality. Okay, and then let's go ahead and solve the next one. We want to get the x by itself, so subtract 8. We get x is less than or equal to negative 8. Now, we have our two inequalities that are going to be separated with an or statement. Now, which one of those is the smaller one? Okay, is 7 the smaller number, or is negative 8 the smaller number? Hopefully you guys can tell that it's negative 8 that's the smaller number. So because negative 8 is the smaller one, I'm going to put negative 8 here towards the left side of the number line, and I'm going to put the 7, because that's the greater one, over by the right hand side of the number line. Okay, so really what I'm going to have to do here, because I'm putting, let's make sure I'm clear about this, guys, because I'm putting the negative 8 on the left side first and then the 7, I'm going to actually rewrite my answers that I just got as, whoops, I'm going to rewrite them as x is less than or equal to negative 8, or x is greater than 7. Okay, so this right here is my statement that I'm going to have to go ahead and find the graph for. So let's see if we can do this. So x is less than or equal to negative 8. So because it's an equal to, I know right away I have to do a closed circle. And which way do I have to shade? Well, it's less than, so I have to shade to the left. All right. Now it has or. Again, remember between here and here, there's an or statement because there's a small gap there. Now I have x is greater than 7. So greater than just requires an open circle, not an equal to, so no closed circle. And then it's x is greater than 7. So where are all the numbers that are greater than 7? Well, they're all over here to the right. So I have my first compound inequality graph, okay? Now, let me go ahead and get rid of these highlights. So that is my graph, guys. This is exactly what I want to see at the end of the problems that you guys are about to do, okay? Now, you don't have to write this or right here. I just write it here to make it clear that we are doing an or problem, because that's exactly what we saw up top in the previous problems. So again, let's do one more together. I want to make sure that you guys understand how this is, how we're doing this, and then we will try a few on our own. So number 8, let's solve the first inequality. I'm going to add 7 to both sides. I get negative 3x is greater than or equal to 15. Now I want to get the x by itself, so I have to divide by -3. And remember, guys, what's the rule? If I divide or multiply by a negative number, I have to flip my sign. So now instead of a greater than or equal to, it's going to be a less than or equal to. And 15 divided by -3 is a -5. So that is my first inequality. Excuse me. Okay, let's go ahead and solve for the next one. I'm going to get rid of my 11 first. So what do I get? I get -2x is less than or equal to -20. Again, I'm dividing by a negative number here, so I have to flip my sign. So I get x is greater than or equal to 10. So my final answer here is x is greater than or equal to 10. Now, if you guys remember from the problem number 7, I asked which of these two numbers from my two solutions, the -5 or the 10, is the smaller one. Well, it's -5. So because -5 is the smaller one, that's the one that I'm going to put here towards the left. And the 10 I'm going to put here towards the right. Okay, so that's how we're going to do all these problems, guys. As soon as you see an OR problem, you know you're going to put a number to the left of the number line and one to the right of the number line. So identify which one's the smaller one, because all the smaller values go to the left and all the greater values or larger values go to the right. So now I can go ahead and start graphing. So again, remember, this is an OR statement right here, guys. So it's x is less than or equal to -5. So let's go ahead and graph it. This takes a closed circle because it's an equal to, and it's x is less than is to the left. All the values to the left of -5 are solutions. So this is my graph to the left. Now the one to the right also takes a closed circle because its x is greater than or equal to 10, and because it's greater than, that is all the values to the right. So this is my graph. And now remember, guys, see how there's a gap right here? So that gap means we are graphing this correct, because whenever we see a gap, we know that it has to be an OR statement, which it originally was. Okay? Alright, I think that'll be good for practice for now. So go ahead and try out number 9 and number 10 on your own. And if for some reason something doesn't quite make sense, we'll come back and take a quick look at it. Okay? So what I want you guys to do just for now, for 9 and 10, just go ahead and solve the inequalities and graph them. We'll go ahead and go through part A and B together when we come back. Alright, so go ahead and pause the video and try those two out. Alright guys, let's go ahead and try out number 9. So let's solve for y. Subtract 1, subtract 1. So I get 3y is less than 3. Divided by 3, and get y is less than 3 divided by 3 is a 1. So this is my first solved inequality. Let's solve the second one. I'm going to add 4 to both sides. I get -1/2. Y is less than a -3. Now, here, in order to get rid of a -1/2, I have to multiply by its reciprocal, which in this case is a -2. And that -2, again, is negative, so we are going to have to flip. Remember, anytime you multiply or divide by a negative, you have to flip. So this becomes y, and now it's greater than a +6. Alright, so once again, I have my y is less than 1, y is greater than 6, so identify which one of those two values, either the 1 or the 6, is the smaller one. We know that it's 1, so I'm going to put the 1 here on the left, and I'm going to put the 6 here on the right. Alright, so let's go ahead and graph these. So I'm going to take a different color here. So this is 1 and 6. Alright, so this is just less than, so I don't have to do a closed circle, just an open circle. And it's less than, so we know we have to shade to the left. Okay? Now in my other one, y is greater than 6, I know it's an open circle. Once again, there's no equal to. And we have to shade to the right. Alright. Cool. Now, number 10, let's go ahead and solve it. Actually, before we even do number 10, let's go ahead and look at the answers, or rather the questions that are being asked in part A and B. It says, is x equals 0 a solution to the above inequality? Why or why not? Okay, well, think about it, guys. Where would 0 be in this number line? What numbers are between 1 and 6? And here that is the non-shaded region, right here. Well, it would be like 2, 3, 4, 5, right? Well, 0 would be less than 1, so 0 would actually be over here. So you ask yourself, is 0 in the shaded region? Yes, it is. So you would say, yes. X equals 0 is a solution because it falls in the shaded region. So again, all the values that were less than 1 are part of our solutions, and all the numbers that are greater than 6 are part of our solutions. So yes, 0 is less than 1, so it's definitely part of our solution. Okay? Part number B said, name a possible solution to the above inequality. So again, anything that falls in that shaded region. So what about maybe like, let's say, what's greater than 6? Maybe like 10? So you would say x equals 10. Now there's multiple answers here. You could have said x equals 10. You could have said x equals negative 20, because that would be to the left of 1. You could say x equals 1,000,000, because that's greater than 6. Okay? Alright. Give me 1 second, guys. I'm just going to switch over here to another desk, and I'll get back to you guys. Alright, so give me 1 second, guys. I'm so sorry about that, guys. I actually had to move desks right now because there's a giant storm outside, and it was getting way too loud upstairs. So let's go ahead and look at number 10. So let's solve this inequality. How do we get rid of this negative 2/3 in front of the x? Well, we multiply by its reciprocal, which in this case would be negative 3/2, negative 3/2. And because we're multiplying by a negative, we have to flip. So it's x is greater than, well, let's see, negative 4 times negative 3/2 is a positive 6. Okay, so I have my solution to my first one. Or, let's figure out the second one. Subtract 7, subtract 7, so I get negative 2x is greater than or equal to negative 2. Divide by a negative 2, which again, it's a negative number, so I have to flip. Anytime you multiply or divide by a negative number, you have to flip. So it's x is less than or equal to a positive 1. Okay, so once again, guys, which number is the smaller one? Well, in this case, it looks like 1 is the smaller one. So if we had to rewrite this problem to make sure that the smaller one's on the left and the greater one's on the right, we would actually rewrite it as x is less than or equal to 1, or x is greater than 6. We weren't asking you to rewrite it, so that's totally fine. But remember, if you are asked to rewrite it, guys, make sure you always write your smaller value on the left and your greater value on the right. So let's go ahead and write our smaller value on the left. So, whoops, not a negative one, it's just a regular positive one. And 6 on the right. So let's go ahead and start graphing. So we have a closed circle here at 1 because we have an equal to sign. And we're going to shade to the left because it's less than. So what are all the numbers that are less than 1? Well, things like 0, -1, -2, -3, and then you can go on forever. Okay? Now, the second part, so it says x is less than or equal to 1, or, so remember here's an or, x is greater than 6. So let's make an open circle, and we're going to shade to the right because greater than is to the right. Okay, guys, give me 1 second, please. Sorry about that again. All right. Alright, sorry about that again, guys. I had to check upstairs because it's getting pretty nasty out there. There's a big thunderstorm going on. But anyways, let's go ahead and continue on with part A of problem number 10. So it says, is x equal 10 a solution to the above inequality? Well, think about it, guys. Where would 10 be in this number line? Well, the number 10 would be somewhere over here, right? We'd have like 7, 8, 9, 10. Is that in the shaded region? Yes. So we would say yes. X equals 10 is in the shaded region. So it is a solution. Okay? And finally, for part B, it says, name a possible solution to the above inequality. Well, again, it's just finding a number that is in the shaded region. And we have two different shaded regions. We have this one here on the left, and we have the one on the right. And actually, I already started doing a few numbers here. So that -1 is part of our solution. So x equals -1 is a solution. Okay? Now you could keep choosing different numbers. X equals 0. Now let me ask you this, would x equals 3 be a solution? No, that would not be, because x equals 3 would be somewhere right here, and that is definitely not in the shaded region, so that would not work. Okay, so any of these two answers or anything within the shaded region would work as a possible answer for part B. Okay, let's take a look at these last two problems and we will be done with today's video. So now we're just, again, continuing on with solving inequalities, now with a few more steps, but again, nothing we can't handle. So this is 4 minus 4k plus k is less than or equal to -8. So before we start doing any division or anything like that, we can combine like terms right there. So we have 4 minus 3k is less than or equal to -8. Okay, got to get rid of the 4. So we get -3k is less than or equal to, that is a -12, right? Now finally, I have to divide by -3 because I'm dividing by a negative number. I have to flip. So I get k is less than or equal to a positive 4. Alright. Or, again, we're going to have an or statement, so we're going to have arrows pointing to either direction when we're shading. Let's solve this one. I see variables on both sides of the inequality, so I always, as a rule of thumb, try to move the smaller one if I can. So I get 3k minus 1 is less than or equal to 8. Now I'm just simply solving for k. So I'm going to add 1, 3k is less than or equal to 9. Okay, divided by 3, divided by 3. Now, here, let's see. I want to double check. Oh, you know what? Let's go ahead and finish this, and then I'll come back to something I forgot to do. So it's k is less than or equal to 3. Now, I want to point something out, and actually, the fact that this mistake happened is a good sign that, or not a good sign, but it's a good way of us to analyze why this cannot possibly be an answer. Notice how here I have k is less than or equal to 4, and here we have k is less than or equal to 3. So if I were to graph this, they would both be pointing to the left. We can't have that. For OR statements, one goes to the left and one goes to the right. So somewhere on here I didn't do something right, and I already know what it was because I spotted it and I forgot to change it. It's this. I didn't flip my sign. I said I was going to, but I never did flip it. So let me go ahead and flip my sign. So this in fact should be, instead of a less than or equal to, should be a greater than or equal to. Alright, so again, identify your smaller number first, so we know which one goes on the left. Well, it looks like 3 is the smaller number and 4 is the greater number. So 3 goes on the left, 4 goes on the right. So let's go ahead and see. This k is less than or equal to 3 is the first one I have to graph. So I'm going to go ahead and do a closed circle, right? And I'm going to shade to the left, right? So I'm going to shade to the left because it's less than. All the numbers that are less than 3 are all to the left. Now I'm going to go ahead and shade my k is greater than or equal to 4. So again, a closed circle. And it gets shaded to the right. Again, all the values that are greater than 4 are to the right. Okay? Now, again, guys, if you guys have noticed on the above problems, I actually would have rewritten this problem right here. Because, look, the k is greater than or equal to 4 is the greater value, so that should be on the right, just like the graph is. Okay? So I'm actually going to rewrite this problem using the same exact information. I'm not going to change anything, so don't get worried that I'm going to change anything right now. But I'm just going to go ahead and rewrite it as k is less than or equal to 3, or k is greater than or equal to 4. Notice now, this is my graph for this is my graph for that. Okay? Always your smaller values first, and then your greater values afterwards, so to the right. Okay? So that's how I would have rewritten the answers to this problem. Again, in this particular case, we're just being asked to graph them, not to rewrite it, so don't worry about that part just yet. But if I do ask you to rewrite it in the correct order, that's how you would do it. Okay, now for part A, all it's asking is x equals 3 a solution to the above inequality? So I want you guys to think about it. Is k equals 3 a solution? Well, k equals 3 is right there in this little red dot I'm making. Okay? It's shaded, so in order to be a solution, it has to be in the shaded region. So this is definitely a solution. So x equals 3 is a solution because we have a closed / shaded circle. Okay? Because it's a closed rather shaded circle, then it does exist in our solution set. Okay, now if they would have said is k equal 3 a solution, and I would have had an open circle, like let's say this would have been an open circle like that, then no, it would not have been a solution. But in this case we don't have that, so we don't have to worry about that. Okay, alright, let's go ahead and do the last problem here, and we will be done for this section. So we have to distribute here. We get 2w plus 4 is less than negative 3w plus 8. Alright, all we have to do now is solve. Again, I see variables on both sides, so I'm actually going to move the smaller variable. So I'm going to add 3w. I get 5, whoops, let me use the different color here. 5w plus 4 is less than 8. Okay, now I want to, oh, I forgot, I didn't distribute right. Sorry about that, guys. This should have been an 8. Good thing I was looking back at my problem. Okay, so if you spotted that error, good for you. Again, guys, if you ever see me make a mistake like that and I don't come back to correct it, please correct it for me, guys. It happens. Sometimes we make mistakes. Okay, so here I have to get rid of the 8. Okay, so subtract 8 on both sides. Well, what do I get? I get 5w is less than 0. Divide both sides by 5. I'm dividing by a negative number, so no need to change the symbol. So I get 0 divided by 5 is just a 0. So because I did spot that error, let me make sure I didn't make any other errors. So if I distribute, get 2w plus 8. Nope, everything else looks like it's good. But again, if you did spot an error, guys, let me know. Alright, now we have to do this right hand side because we have an OR statement. So again, we're going to have arrows pointing to either direction. Let's distribute. I get 1 minus 2w minus 2 is greater than negative 6w plus 7. Before even moving any of the variables, I notice right away I have like terms here. So let's go ahead and combine those. So this is a negative 2w minus 1 is greater than negative 6w plus 7. Move the smaller variable first. In this case, it's the negative 6w. Again, if you're not sure, think about it this way. Since they're both negative, you ask yourself which one's more negative. Okay, that's basically the smaller value, or the smaller variable term. So in this case, if we add the 6w to get rid of that, we get 4w minus 1 is greater than 7. Add the 1, because we want to get the w all by itself. We get 4w is greater than 8. Last step. Divide by 4. And again, no need to change the symbol because I'm dividing by a positive 4. Only when we divide by a negative. Okay? Now, the smaller value already I can see is on the left already, and the greater value is on the right, so there's no need to rewrite this one. I'm actually going to go ahead and go straight to just writing an OR. So it's w is less than or equal to 0, or w is greater than 2. And I think on accident I said w is less than or equal to 0. It's just w is less than 0, meaning just an open circle, and I shade to the left. All the numbers to the left of 0 are less than 0. And finally, on the 2, we have an open circle yet again because there's no equal to, and we shade to the right. Again, guys, if it helps, think of these little things as arrows. That looks like, well, not really, not right now. If you originally had this, if you make a little line through there, it kind of looks like an arrow going to the left. This kind of looks like an arrow going to the right. That way you know which way you have to shade. So those are just little tricks on how to do this, guys. If you don't want to use those, that's totally fine. All that I ask is that if you do use that trick, make sure the variable term is on the left side. Okay? Now, part B, ask, is 0 a solution to the above inequality? Well, where is 0? 0 is right here. Is that a shaded region? And you would say no. Why is it not a shaded in the shaded region? Because it's not a closed circle, it's an open circle. So you would say no, x equals 0 is not a solution because it is not in the shaded region. And basically, to kind of add to your argument, you could say something like, it is an open circle, not a closed circle. Okay? Alright, guys, so again, just a quick recap. Whenever you see an inequality, like let's say, for example, you're given a graph, and you're trying to figure out what kind of inequality is that. Is that a regular inequality, or is it a compound inequality? Well, it's a compound inequality because you see two shaded regions, right? You see one to the left and one to the right. So it either has to be an and or an or. Well, we haven't even talked about and yet, but the way you can tell that it's an or is because you have a gap right here. Okay? You either go to the left or to the right when you're shading. Okay? Besides that, if you see, well, if you start with the equations, kind of like what you did on number 11 and 12, like that, and you see that automatically they tell you it has to be an or statement, then you know at the end of the day you're going to have to graph something that goes both to the left and to the right. Okay? And I think that's it for quick summary on this section, guys. Just so you guys know, tomorrow we will be looking at and statements. Okay, they're going to be almost, I guess in a way, they're almost like the exact opposite. Meaning that instead of going both to the left and to the right and leaving a gap in the middle, and statements will actually be that gap in the middle. So you won't shade left or right. There'll be something that's being shaded between. So in this example, like number 1, it's going to be something that is like right here. Only that orange spot is the solution set now. But again, we'll talk about that tomorrow, so no worries about it right now. Go ahead and try your homework to continue on with this lesson to see if you fully grasp this concept. Okay, guys? Alright, I'm going to go ahead and end the video here, so I will talk to you guys soon. Bye.